Good afternoon, everyone, and welcome to our webinar, Advanced Perimeter Fire Containment Systems for Vertical Notched Curtain Wall Designs. I'm your host, John Zalepka, the Training and Development Manager here at STI. We'd like to take a moment to review some housekeeping items before we start. All attendees will be muted during the webinar. We've disabled the chat feature, so if you do have questions, please type them into the Q&A section, and we'll have a discussion at the end of the program. We will be reporting AIA credits for those who attend at least 75% of the live webinar. So if you have an AIA number and you did not give it upon registration, please email it to webinars@stifirestop.com. If you're not a member of AIA, STI will still be sending certificates of attendance for you to self-report to whatever agency you wish. And in addition to your certificates, STI has partnered with Credly to provide you with a digital badge of your credentials. We'll also be sending a recording of this presentation to everyone who registered. Please allow 7 to 10 business days for the generation of certificates, badges, and the recording. So the value of understanding the performance of vertical notch system in today's ever-changing complex designs cannot be overstated. Our presenter today is Eric LaCroix, Director of Strategic Accounts, who will help us identify the unique challenges that these assemblies present in the design phase so that you can eliminate costly changes, delays, and compromised life safety requirements prior to construction. This information has been developed by Specified Technologies and is copyrighted, so please do not reproduce, redistribute, or display any materials without contacting us first. As I mentioned, this course has been approved for one CEU with AIA, that's an LU HSW, and the session has also been registered with the ICC. At the end of the program, you're going to be tested on your knowledge of the following learning objectives. You will be able to define what a perimeter fire containment system is. You'll be able to identify the code requirements for those systems. You'll be able to describe how vertical notched curtain wall assemblies perform in a fire. You'll understand how to read a tested design, and you will recognize the complexity of vertical notched curtain wall assemblies and how to address them. And with that, I'd like to turn it over to our presenter today, Mr. Eric LaCroix. Welcome, Eric.
Thank you so much, John. I'd like to welcome you to today's advanced curtain wall training and thank you for the opportunity to speak with you. As mentioned, my name is Eric LaCroix and I will be your presenter today. I'm the Director of Strategic Accounts for Specified Technologies Incorporated, overseeing the curtain wall division, and I'm considered the Firestop industry's curtain wall specialist. Just a little background before we begin. STI is a privately held worldwide manufacturer founded in 1990 and is the technical leader in the firestop industry. STI's corporate headquarters are located in North America with regional offices in Europe, Middle East, Singapore, Latin America, India, and the Far East and China. We are the only manufacturer with 100% focus on the firestop industry, and our mission is simple: to provide the most innovative and cost-effective firestop solutions. Today's presentation has been developed from overwhelming requests for the latest advancements in testing for vertical notch curtain wall systems and is designed to assist you in avoiding headaches and delays down the road that cost you money. We will have time at the end of today's presentation, as mentioned, to answer any questions you may have, so please feel free to ask. Our discussion topics will cover the evolution of code consistency, the importance of testing for perimeter fire containment systems covering ASTM E2307 and the ISMA, in addition to understanding how to read tested systems. We'll also cover understanding the complexity of vertical notch curtain wall designs, focusing on both traditional galvanized backpan assemblies, as well as the newer galvanized valance backpan assemblies. We'll also provide an ST update, and again, we'll have time at the end for questions. So as we continue to reach higher and higher throughout the world, perimeter fires continue to be an increasing problem. Whether contained and controlled or devastating and heartbreaking, perimeter fires leave a lasting impression. They change the way buildings are designed, how they are built, how they are inspected, and most importantly, they change the court of public opinion. The starting point is to always have a solid understanding of the code requirements. And the great news is the codes have finally established consistency, starting with the 2012 IBC and continuing with the adoption of the 2015 and 2018 IBC codes. State building codes have also been adopted, incorporating the IBC verbiage to supply a consistent message across the country. protection of the void created is mandatory in all building codes, period. The IBC documents specific language to outline the requirements and further eliminate confusion. 715.4 exterior curtain wall floor intersection states, voids created at the intersection of the exterior curtain wall assemblies and the rated floor ceiling assemblies shall be sealed with an approved system, not materials with known fire resistance properties. These systems shall be securely installed, in other words, mechanically fastened in place, because simply friction fitting and the insulation and taping to the frame will not pass the test standard. These systems must be tested in accordance with ASTM E2307, which we'll cover in detail shortly, and they are required to provide an F rating equal to that of the floor or roof deck itself. That is the code requirement. In addition, Canada has finally adopted the ASTM E2307 requirements into the 2018 S115 Canadian Code, and the language has also been incorporated into the 2020 NBCC, which was targeted for release December of 2021. The release of all the codes, the updated codes, has been delayed due to the COVID pandemic. So, we are staying on top of the release of those codes on a monthly basis. So let's discuss the importance of testing for perimeter fire containment systems, focusing on ASTM E2307 and the ISMA. And again, we'll also review how to read tested systems. All perimeter fire containment systems are tested to ASTM E2307, which is the standard test method for determining fire resistance of perimeter fire containment systems using the intermediate scale multi-story test apparatus, which for obvious reasons is commonly referred to as the ISMA. And this is a very severe and critical test to pass, and it differs in three critical ways from how standard construction joints are tested. First, this test is run between a rated floor or roof barrier and a non-rated exterior curtain wall assembly. If you think about it, every single other construction joint that is in the fire stop industry is tested between two rated barriers, a rated floor and a rated floor, a rated wall and a rated wall, a rated floor to a rated wall, and so on. This test requires a non-rated exterior wall to a rated barrier, different test standard. Secondly, the test measures the performance of the perimeter fire containment system and its ability to maintain a seal to prevent the interior spread of fire during the deflection and deformation of the exterior wall assembly itself. You're dealing with a non-rated exterior wall assembly. It's going to twist and buckle and come apart in chunks. If your perimeter fire containment system cannot compensate and adapt and adjust for the movement and deflection, you'll fail the test. And last, the curtain wall and the joint itself are burned from below, but also from the exterior to mimic how high-rise fires perform. It's one of the unique features of the test standard, as it incorporates both an internal and an external burner. And as you know, compartmentation, which really is nothing more than dividing space into smaller units by basically construction rated boxes, and these boxes are designed to limit the spread of fire, toxic smoking gases to their point of origin. This allows occupants to get out and first responders to get in, is critical in fire protection for life safety. But in curtain walls, structural integrity is also critical, because if the wall comes off the building, the joint goes with it. We must protect the components of a non-rated curtain wall system as long as possible to be successful. The fire will attack any unsealed voids at the floor line on the interior side while breaking out the vision glass on the floor below. The fire will then attack the framing system and spandrel or closure panels from dissimilar planes, from both the interior as well as the exterior of the building. Combustibles on the floor will ignite, occupants will perish due to smoke inhalation, and in the worst case scenario, both compartmentation and lives are lost. It's important to note exactly how critical and severe the ASTM E2307 test standard is for perimeter fire containment systems by looking at the ASTM E119 time temperature curve used during the test. Note the melting points of rigid foam panels at 300 degrees Fahrenheit, spray foam at 392 Fahrenheit, zinc melts at 790 degrees Fahrenheit, and aluminum alloys begin to soften at 800 degrees plus Fahrenheit. At 9 minutes into the test, we start to lose lower framing members at 1200 degrees plus Fahrenheit, and we are already starting a critical stage of protection that must last for another 1 hour and 51 minutes. So let's take an in-depth look at the ASTM E2307 test requirements and the ISMA. Here we can see a recent full-scale ASTM E2307 test on the ISMA. On the left, you can see the size and scope of the test that was run, while on the right, you can see the galvanized back pin assembly in relation to the floor slab itself. And here you can see the internal burner gating intensity at the very beginning at the start of the test. Roughly 5 minutes into the test, the external burner is lit, and this will focus the flames and heat on the exterior of the wall assembly to replicate the performance of high-rise fires. And here you can see the start of both the internal and the external burners merging and gaining in intensity in only a few minutes of the test. And here you can see the test in full force. We are starting to see critical components of the wall system start to fatigue rapidly, and it is not uncommon to see flame plumes of up to 10 to 12 feet during the test. Here we can see the vertical mullions on the left are bowing, twisting, and giving way, while on the right, you can see the horizontal transom below the floor line has melted out. This is due to the severity of the heat and flames during the 2307 test. And with the vertical and horizontal framing compromised, the thermal expansion of the backpin assembly comes into play, and the issues with galvanized backpin assemblies under fire conditions become obvious. On the pic on the left, you can see the backpin assembly is deflecting and warping as the framing weakens. Note the lower leg of the backpin assembly pulling away from the mineral wool weld pin to the backpin itself. On the right, you can see how the flames on dissimilar planes attack the assembly. The loss of the framing, the loss of critical fasteners, and the warping and twisting of the assembly itself will cause the backpin to lose integrity and eventually fall out of the framing system. And here you can see at the end of a 3-hour test, note the assembly is glowing red hot. On the right, we can see the impact to the galvanized backpin assembly as it is twisted, warped, and stressed the fasteners, causing them to fail. And here you can see the impact, again, of the 2307 test standard on the wall assembly itself. And although it looks pretty bad on the exterior of the building, the perimeter fire containment system is performed as designed to prevent the interior spread of fire per the IBC 715.4 requirements, keeping critical components of the wall itself intact for a longer period of time. Remember, perimeter containment requires the extension of the rated floor to the non-rated exterior wall. The perimeter fire containment system, the sealing of the perimeter joint, and the extension of the rated floor all provide structural protection and maximizes the integrity of the wall system at the floor line itself. So once the test is successful per the ASTM E2307 requirements, a tested design is listed and published. Both UL and Intertek test to the same ASTM E2307 standard, but they have unique aspects to both labs. UL has some advantages for specific designs that they run. The ISMA configuration for backpans, anchors tested in designs, as well as realistic movement requirements. At Intertek, they have advantages for their specific designs as well. All vision glass systems, hybrid window walls, and wider mullion spacing are advantages at that lab. STI utilizes the best aspects of both labs for tested designs that are proven under real-world fire conditions. Well, that's great, Eric, but what exactly does a system mean and how do I read them? Well, that's a great question. Well, the good news is when it comes to perimeter fire containment systems, they are easy to understand. At UL, Tests are broken into a set of alpha characters and a set of numeric components. The first set of alpha characters must be CW. Well, what do you think that means? Right. CW stands for a perimeter fire containment system tested for ASTM E2307 on the ISMA. The second set of alpha characters will be either an S or a D referencing either a static or dynamic design. Please note that in the perimeter fire containment world, static systems are completely acceptable. UL historically referenced movement as compression extension, like in rated construction joints, like head of wall. As curtain walls do not move like that, they developed a cycling method listing vertical shear movement, like wind sway and thermal expansion, which is much more applicable to perimeter fire barrier systems. The next section will list the numeric component. The first number will always reference the width of the joint. The 0 series are for joints up to 2 inch, the 1000 series are for joints up to 6 inch, and the 2000 series are for joints up to 12 inch. Now, it doesn't mean that that specific test will have that maximum joint width. It means that that system will be found in that joint width range. And then the last 3 numeric components list the test number in a series. So CWD 1044 is the 44th test run for a perimeter fire containment system for a joint width in the max 6 inch range as tested per ASTM E2307 on the ISMA. It's that simple. Well, at Intertek, the numbering system is a little different. Numbering system STI BPF 18002 is broken down as follows. STI is the manufacturer identifier. BPF identifies it's a barrier, perimeter fire tested per ASTM E2307 requirements on the ISMA. The 180 is the hourly rating in minutes. So this would be a 3-hour F rating. And the 07 identifies this is the 7th system in this grouping. And again, it's that simple. So what's the big deal with ASTM E2307 published tested designs? Well, there's absolutely many. First and foremost, published systems meet the code requirements outlined in the definition section of the building codes and are subjected to follow-up services by the labs. Listed is defined in the code under Chapter 2 as equipment, materials, products, or services included in a list published by an organization acceptable to the building official and concerned with the evaluation of products or services that maintains periodic inspection of production of listed equipment or materials, or periodic evaluation of services whose listing states either that the equipment, material, product, or service meets identified standards or has been tested and found suitable for a specific purpose. In other words, the installation for a fire-resistant joint system is not code compliant unless it is installed using listed products in a listed system by an approved third-party agency. Also, because of this, published system designs are well recognized and respected by architects and inspectors. They limit the job delays and stoppages by eliminating concerns, which saves money by keeping the project on or ahead of schedule. It limits liability and exposure to all parties involved. But for us, the real reason is tested published designs work in real fire conditions. This is from a fire we were involved in New York City. If you look at the spandrel panels, you can see exactly where the most severe area of the fire occurred. On the far right, you can see the panels starting to melt. Moving to the left, you'll see the black panels, the spandrel panels gone, and only the spandrel insulation, the tan material, is showing. While moving further to the left towards the center, you see only the section of spandrel insulation and the saping insulation at the actual floor slab that has been held in place by the tested fire stop system in the spray. When you go on the floor where the fire broke out, this is exactly what you'll see. The failure of the wall system is exactly what will happen. The aluminum framing, the vision glass, and the spandrel panels are completely gone. However, when you go on the floor above, the aluminum framing are all intact, the anchor is protected, and the void is completely sealed. The perimeter fire containment system did its job. The next section focuses on understanding the complexity of vertical notch curtain wall designs incorporating both traditional galvanized backpan assemblies and the newer galvanized cutting-edge balanced backpan assembly designs. So the starting point is to understand what is a vertical notch curtain wall system and why would you use one. So using an overview based on the U-Wall system by Reflection Window and Wall of their vertical notch curtain wall system, their design offers the following advantages. It greatly reduces the structural eccentricities found on a typical curtain wall anchor by a factor of 5 to 6. The design unifies the anchor components into the panel directly, so the unit acts as the anchor. The result is the U-Wall system can be installed with about half the crew size in less than half the time of a typical system because the unit is the anchor. And last, the vertical notch of the mullion brings the system's face of glass closer to the slab edge, which allows for infinite design flexibility on the interior. Their patented adjustable interior trim also allows you to perfectly finish any floor you want without the unsightly caulk joints normally occurred. So here we can take a look at the vertical notch curtain wall system. So first of all, the system allows for a 1 or 2-piece framing. And here you can see the vertical notch curtain wall frame clearly at the back of the system. Note it is completely open and it will absolutely cause serious issues quickly if not protected properly. It allows for both a wet zone and a dry chamber within the mullions. And the system also allows for a single or double chicken head. And last, you can see the galvanized backpan assembly. And again, this is what's known as a balanced backpan assembly, which is absolutely on the cutting edge of how these designs are fabricated. And on the left, you can see the galvanized balanced backpan assembly installed and the vertical notch of the mullions itself. Well, on the right, you can see again the vertical notch of the mullions and the mineral wool that has been installed within the vertical notch on site. So here on the left, we can see the wall system installed, ready for the 2307 full-scale test to be started. While on the right, you can clearly see the impact of the test. Note the mullion is twisting and warping quickly. The two-piece notch mullion will open up quickly and start to peel apart vertically at the floor line. And again, here you can see the ASTM E2307 full impact to the framing system in the before and after pictures. Again, note the mineral wool insulation that is installed within the framing system during fabrication and on site has performed as designed and has protected the interior spread of fire for a full 3 hours. And again, here is another pic to illustrate the 2307 test impact to the vertical notch curtain wall system, incorporating a balanced galvanized backpan assembly. And again, note the mineral wool insulation has been installed in the vertical notch area and in the framing itself has performed as designed. Without the insulation in the framing, the test would absolutely fail. Remember, a successful perimeter fire containment system stops the interior spread of fire and provides protection by keeping the wall and the window system intact for a longer period of time. If the wall comes off, the joint goes with it. So galvanized backpan assemblies make an already difficult condition even harder. The backpan itself is a critical condition that must be addressed due to their complex performance in various conditions. But don't take our word for it. Let's look at UL's stance from 2011. UL documented their concerns about engineered judgments being issued for perimeter fire containment systems incorporating steel backpans, as only one manufacturer invested in the development of proven, tested, published designs. It has come to UL's attention that engineered judgments for perimeter fire containment systems incorporating steel backpans are being issued despite having no tested or listed designs for curtain walls with steel backpans to reference as the basis for such judgments. Based on our previous testing experience, we have found that the steel backpan condition is a critical configuration from a test perspective. Testing conducted in accordance with ASTM E2307 has demonstrated that the thermal expansion of the steel pan can cause it to distort and deflect, stressing the perimeter fire containment system under fire conditions, and in some cases, causing the perimeter containment system to become dislodged. Also, the fill material, the fire stop spray, applied over the safing system in the perimeter fire containment system can also be exposed to a significant amount of heat from the steel backpan and could cause ignition of the sealants or coatings during the course of the fire exposure. Again, this is another reason why published systems are critical, because they are subjected to follow-up services from the labs. The issue with galvanized backpans are that they twist, buckle, and warp due to the thermal expansion of the steel. Most refer to this movement and deflection as oil canning. This is eliminated with the use of a stiffener at the floor line when the transom is raised off the slab. If the system requires a stiffener at the floor line and one is not installed, the deflection of the pan can tear the spandrel insulation apart in the assembly and dislodge the packing material at the floor line, resulting in failure. And here we're going to show you the results of a raised transom design incorporating a heavy gauge backpan for a raised transom condition with no stiffener included. This was from a project years back where the designers and the fabricators wanted to use a heavier gauge backpan and felt that it would handle the deflection. And so we actually tested it for them. So here you can see the results, and with a joint being set at 3 inches. At 10 minutes into the test, the joint had deflected to 2.5 inches. At 15 minutes, the joint was 2 1/4. And at 20 minutes, the joint had deflected to 1 3/4 of an inch. The test was stopped at 20 minutes due to the oil canning of the pan itself over various areas, as we could tell there was interior damage happening. And when the assembly was removed from the furnace, the back pan fell out. This would be an example of back pan units failing, commonly referred to as panel shedding. And here's another example of the complexity of the back pan assemblies by looking at the seams that opened up in the curtain wall insulation that was weld pinned to the pan itself. Here you can see the transfer of heat through the seams caused the pan to deflect, which in turn caused the seams to open up wider, which in turn caused the pan to deflect more. This is a never-ending cycle that eventually will lead to the assembly's failure. So let's take a look at the requirements for galvanized backpan assemblies in today's modern configurations. In general, backpan assemblies must be a minimum 22 gauge galvanized steel located at the back of the system, which is the most common application, or towards the front of the system, referred to often as a wet zone. Backpan assemblies must be mechanically fastened to the curtain wall framing with steel screws spaced max 8 to 12 inches on center. Testing is available, allowing the backpan to be recessed a max 1 inch from the back of the system. And certified curtain wall spandrel installation is mechanically fastened to the galvanized backpan with cup head weld pins spaced max 12 inches on center. And last, a stiffener is required within the assembly if the underside of the transom is raised off the floor slab. So let's take a look at a couple key areas. Again, certified curtain wall spandrel installation must be secured to galvanized backpan assembly, max 12 inches on center. This is generally done with either cup head weld pins or steel weld pins with clinch shields. If a seam is allowed in the tested design, a fastener is required a max 6 inches from the seam, and a minimum of 2 fasteners are required per section. So let's discuss one of the most overlooked requirements of a backpan assembly, the stiffener. Stiffeners are required for all designs if the transom or sill is raised off the floor slab. There are no tested designs omitting this critical component. Here's an example of a raised transom design with a minimum 22 gauge galvanized stiffener easily tack welded to the pan during fabrication in the shop. It is critical to reference the tested designs that are being used to formulate any type of EJ to understand the specific requirements of that system. Here you can see the requirements of an insulated or a pre-insulated minimum 18 gauge, 4-inch wide by 3-inch deep custom stiffener with 1-inch return legs that is required to be screwed to the pan, breaking the vapor barrier. In addition, you have to add steel patches along the 18 gauge custom stiffener and then add additional 1.5-inch galvanized angles 12 inches above and 12 inches below the floor slab. This is what's required in this specific manufacturer's test to pass that condition. It is unethical for any firestop manufacturer to write engineering judgments referencing back pans may be appropriately stiffened per methods described in any UL or Intertek approved perimeter joint system, as all tests are specific to a manufacturer. A common condition that still occurs but results in major headaches, delays, and costs is when a required stiffener is not installed in the shop during fabrication. In the past, the units would have to be torn apart or the project would have to accept a cold smoke seal for the rating on the perimeter, both of which really aren't realistic. But please note that there is a tested design now to address this common condition easily by allowing the stiffener to be mechanically fastened on the void side while the units are hung or during the fire stopping of the void itself. Please note that a stiffener is not required to pass the ASTM E2007 testing when the transom is flush with the top of the slab in specific tested designs for back pan assemblies. Also note a stiffener may not be required to pass the standard when the transom or the extrusion is recessed below the slab in a specific test. It is always recommended as best practices to always confirm the requirements of the tested design that either you're using or that engineered judgments are being written off of. So let's discuss the traditional galvanized back pan assemblies in general. Here you can see the back pan assembly being dropped into the units in the shop. The units are then mechanically fastened to the framing per the system requirements. In some advanced high-performance designs have been tested to address the continuous gap that many fabrication companies use. In the pic on the far right, you can see the gap is treated with standard all-weather sealant at the front of the system during fabrication, and nothing additional is needed. In the image on the left, we see the assembly being ready to be tested. Note the spandrel installation well pinned to the galvanized back pan assembly. On the right, we added an optional aluminum shadow box so that you can see how it would look with a clear spandrel panel or all vision glass panel. The lower area in blue references the vision glass area. Here you can see the impact of the framing and the back pan assembly starting on the left, and the eventual failure of the back pan assembly itself and falling out under fire conditions on the right. And again, here's a side-by-side comparison for reference on the impact of the test itself. So let's discuss the growing use of what is known as balanced back pan assemblies. These have been developed and used to replace non-effective all-vision glass assemblies that have become popular in many of today's complex projects being designed. On the left, we see the positioning of the balanced back pan assembly designed to provide the look of all vision glass. On the right, we added a shadow box to reference how it would look in contrast with the building interior. And here you can see the impact of the balanced galvanized back pan assembly under real fire conditions. And again, here is a side-by-side comparison before and after to document the impact of the ASTM E2007 test standard on the ISMO. In closing, code requirements are mandatory. All voids created at the intersection of a non-rated exterior curtain wall and a rated floor or a roof slab must be protected to prevent the interior spread of fire per IBC 715.4 requirements. Vertical notch curtain wall systems present unique challenges and require specific protection. Real-world, published, tested designs exist for these unique wall systems and should be used over non-tested EJs or unpublished solutions. The galvanized backpan assembly must be considered as a critical part of the system itself, and any EJ should be closely reviewed to ensure the manufacturer of choice has tested vertical notch curtain wall systems incorporating galvanized backpan assemblies. So this concludes the AIA portion of today's presentation. We'd like to provide you with an update on what STI has been working on. STI is proud to introduce the industry's first and only published ASTM E2307 full-scale test for vertical notch curtain wall systems. STI BPF 18002 offers many of the industry's first, including the first and only published ASTM E2307 full-scale test, a maximum 3-hour F rating. System protects the vertical notch mullions, the anchor pocket, and the stack joint within the design. Another key feature is it offers a minimum 40.5 on center mullion spacing to address many of today's wider mullion spacing requirements. It incorporates the proprietary Tomahawk anchor system for ease of install. And it also allows for any glazing or an exterior cladding system which complies with applicable building code and regulatory requirements. Allows options for structural silicone or pressure plate and gasket to be used. And lastly, offers an optional angled or straight shadow box on the front of the system formed of any material that complies with applicable building code or regulatory requirements. More firsts in the industry. We offer the first balanced backpan assembly tested with multiple options. Here you can see here, we have an option for just the backpan assembly itself with no transom below the floor slab, only the bent leg of the backpan assembly. It also allows for both captured or kiss framing. And last, it allows for an intermediate transom with an optional angled or straight shadow box. And for the first time ever, it addresses a with-load anchor configuration, which has become very critical in many jurisdictions around the country. And here you can see the mineral wool has been incorporated into key areas of the framing system during fabrication and on site. Here you can see that the anchor head cavity at the front and the anchor head cavity on the underside, as well as the space between the anchor cavities, are protected. Here you see a minimum 2-inch, 8-pound faced or unfaced spandrel insulation that has been fastened to the back pen with cup head weld pin spaced max 12 inches on center, and multiple seams are allowed in the tested design. A minimum 6-inch deep 4 PCF mineral wool insulation is compressed minimum 25%, 25% with the grains running vertically in the void, flush with the top of the slab. And to complete the installation, the final step is the installation of Spec Seal fire stop sprays installed per the system requirements. Again, here you can see the importance of the insulation in the anchor head cavity in the front of the system and in the vertical notch mullions at the end of the 3-hour burn. The installation of proper mineral wool is critical in the performance of any tested design for vertical notch systems. We want you to know that you're not alone. STI is your global fire solution partner. STI owns over 60% of the perimeter fire containment systems tested at UL, with dozens more at Intertek. But having the greatest number of systems isn't enough. It's all about real-world testing. And STI has developed the most complete real-world tested solutions that are published for flush transom backpan assemblies, raised transom backpan assemblies, and now the industry's first tested and published solution for vertical notch curtain wall systems. In addition, STI has also developed tested solutions for wet zone backpan assemblies, as well as all vision glass designs. But not every design is a backpan assembly, and STI obviously has developed the industry's most complete real-world test package for non-backpan designs, allowing the use of continuous angle, hat channel, or the revolutionary quick clip hanger system for spandrel insulation attachment. But that still isn't enough at times for today's modern and complex projects. We also offer complete, tested, and published coverage for precast, EIFS, GFRC, and hybrid window wall designs. Any of these we can discuss more at a later time if you have any specific needs. STI has also invested in the development and testing of the industry's most successful products for perimeter fire containment, including water-based and all-weather high-performance fire stop sprays for perimeter containment, the Quick Clip system, which has quickly become the standard procedure for both shop and field installed non-backpan spandrel installation conditions, as well as the industry's first full-scale ASTM E230 tested solutions for hybrid window walls and vertical notch systems using the revolutionary window wall gasket. But having the industry's best products, testing, and solutions isn't worth anything if you don't have the right people to support you. Because STI is 100% focused only on fire stopping, we can support market segments that have critical needs, including curtain wall and healthcare. STI's curtain wall strategic team has over 45 years of combined curtain wall experience, providing you with unmatched field and office support from design and concept through installation. And to support the strategic efforts for our partners, STI has complete sales coverage throughout North America, broken into 7 regions, supported by both regional manager with multiple territory managers covering the states or provinces in each region. And last, our commitment to supporting our customers' needs is never ending. We offer the unmatched technical support from our engineered services group, which have over 250 years of combined experience through 2 U.S. offices 6 days a week. Our goal is a 24-hour turnaround on engineered judgments and technical support so that you have the information when you need it. And to make our partners' lives even easier, I want to highlight briefly 2 tools we have developed. First is our Handbook of Solutions. And you'll note that my email address is on the slide. Feel free to send me an email, and I'd be more than happy to send you the latest copy. But this is a Handbook of Solutions that is designed to showcase the most cutting-edge perimeter fire containment tests for aluminum frame designs. It's easy to work with, so you don't have to search through over 140 plus tested systems, and is broken down by wall types, insulation attachment methods, as well as anchor types, covering back pans, non-back pans, all vision glass, short panel designs, hybrid window walls, anchor protection designs, and many, many more. And it also includes links and information on all specific tests and products for use in STI's perimeter fire containment systems. We also have a handbook for precast, GFRC, and EIFS designs, or we can actually develop a specific handbook based on your most common conditions. Again, please feel free to email me to receive the latest updated copy. And last, I'd like to share with you a very exciting advancement that we've introduced. We are always pushing the boundaries and have just released the new Design Assist service that allows you to easily and quickly interact with the curtain wall strategic team for all your needs. You can access our new Design Assist feature off our website under the Solutions tab. Select curtain wall and scroll down the page, or you can easily email me directly and we will provide you with a link for all your project teams they can use. Many of our strategic partners have found this to be a tremendous value-added service and have found and have had great success using this with their design teams for project support. And with that being said, we're going to bring John back in and we're going to have a little fun with our Test Your Knowledge section.
That's right, Eric. Great job. Great job. We have some questions for you, but first we're going to see how our listening audience did and test their knowledge. So I'm going to go ahead and launch this poll and we'll read through these questions here. Please answer to the best of your ability, and then we'll go over the answers in just a second. So first question, perimeter fire containment systems are designed to cause headaches and stress, provide better Wi-Fi reception, or extend the rating of the floor to the exterior wall to stop smoke, fire, and gases. Go ahead and make your selection now, and we'll move on to question number 2. All right, section 715.4 in the IBC requires a rating. Is that measured in seconds, equal to the fire resistance rating of the floor slab, or is it to be 0? Go ahead and make your selection now. We'll move on to question number 3. Vertical notch curtain wall systems have unique challenges that must be addressed with tested designs. Is that true or false? All right. Number 4, the vertical notched mullions are required to be insulated with Is it old newspaper? Good intentions? The required depth, density, and compression of approved stone/mineral wool. And our last question, number 5, galvanized backpan assemblies under fire conditions. Do they work like a charm? Do they not require any mineral wool insulation in the assembly? Or do they oil can due to the thermal expansion of the sheet steel? I'll give you another second or two to make your final selections. And we will end the poll. Eric, go to the next slide. We'll see how everyone did. You may need to X out that poll that popped up on your screen there to get the slides back. Yep.
Okay, no problem at all, John.
All right. Number 1, 100% of you got that one right. Perimeter fire containment systems are designed to extend the rating of the floor. Number 2, section 715.4 in the IBC requires a rating equal to the floor slab. 99% of you got that one right. Number 3, vertical notch curtain wall systems are designed, must be addressed with tested designs, and that is true. 97% of you got that one right. Number 4, the vertical notch mullions are required to be insulated with so one person did choose good intentions. We love that person out there. But if you round up, 100% of them got it right. The required depth, density, and compression. And number 5, galvanized backpan assemblies under fire conditions do oil can. So 84% of you got that one right. Great job. It's 100% as a whole. And we'll stop sharing there. Eric, you might need to X that out again to get to that next slide.
Okay,
there's your beautiful mug. There you are. There you are. So like we always do about this time, if you don't mind, leave us some feedback on LinkedIn. We always choose 1 or 2 of you to receive a swag bag there, as you see. So please grab your phones, give Eric a little bit of feedback, and we'll get into the questions. Aaron has been helping us. Aaron Alterman, he's on the curtain wall team there. Aaron, do you have a first question that we want to ask Eric?
We have a handful of questions here, so let's get started. The first question comes from Michael. Is an application not code compliant unless the joint, backpan, and job-specific curtain wall were all tested according to ASTM E2307?
See how to answer this quickly. So basically what you do is you have parameters that you test with. For example, you'll look at a tested design and it will say a minimum 2.5 inch wide by 5 inch deep curtain wall frame. It'll say a minimum 22 gauge galvanized backpan assembly. It'll reference a lot of minimums. And what that does is what you're trying to do is you're trying to test the most coverage you can get. So for example, you're not going to see something like a Cornair 1600 or a specific test listed for a number of reasons. But what you will find is the minimum requirements. So what you want to do when you're looking at your design is, number 1, you want to look and make sure that the parameters of your curtain wall meets the minimum requirements of the design. And from there, if not applicable, then you can contact a manufacturer and talk to them to see if they could put together an engineered judgment based off of some testing. So hopefully that answers your question, but in general, you want to look at to make sure the basics or the outlines of the design are tested. Minimum gauges, minimum spacing, and so on.
Very good. Great answer. All right. Next question is, do window wall systems need to be tested to ASTM E2307?
It's funny because we always get this question, and there's a couple things I want to clear up. First and foremost, the code never specifies the type of wall. We hear people say that a lot. Well, it never says this type of wall, or it doesn't say concrete panel, or this, that, and the other. The code does not specifically say anything about the wall. It says the voids created. It doesn't matter what type of wall it is. So to answer your question, it depends on the type of window wall system. Years ago, traditional window wall systems were done, and they did not need any type of perimeter fire containment protection because the framing actually sat on top and was flush with the face of the floor slab itself, and they would generally just put an aluminum closure panel just to hide the floor slab. But what's happened is they've created a lot of these newer, what they consider hybrid window walls, crossover window walls, some people refer to them as, and what they've done is they've raised the framing off the top of the slab and the bottom of the slab, and they've pushed it off the edge so it cantilevers over the slab. So now you've created 3 voids that have to be addressed. So to answer your question, if it is a window wall system that creates a void, then absolutely it has to be tested per ASTM 2307.
Great answer. All right, next question. This is a leapfrog question, Eric. If the fire bypasses the floor and leapfrogs through to the floors above, going through the glass, but the assembly remains intact, is that considered a pass?
Yes, it is a pass. And the reason being is because there is no evaluation on leapfrogs. There's been standards that have been trying to been adopted, but there's many problems with a lot of the things that go on. And you know, the truth of the matter is, if we really want to talk hard numbers, it took years to get a lot of these designs tested per the 2307 for real world conditions. I mean, let's be honest. How many wall systems do you see out there that have, you know, a raised transom 36 inches off the slab and are 70 inches overall? That's not a real world condition. So the industry has moved forward, and, you know, tested designs exist for all types of configurations, but there's all types of issues that happen. You know, vision glass is going to break. It breaks on the floor above. That's part of the test. But again, it's not a failure. It's just what happens with glass.
All right, another great answer. All right, last, we have actually two left. One is a two-parter. So are any curtain wall anchors that protrude past the bottom of the safing, does that need to be protected? And if so, what code is being referenced? And part B to that is, how does that relate to either steel and or aluminum anchor systems?
Oh man, we're getting into the weeds. I love it.
Right.
Okay, so anchor protection, exposed anchors. First and foremost, you have to determine, number one, is it dead load or wind load? There are no code requirements right now, but many jurisdictions, especially advanced curtain wall consultants, are aware of the issues with an exposed dead load anchor, and they are requiring protection. Areas, for example, in California, San Francisco, things like that, those types of areas, it is a requirement to protect the anchor system regardless. So there's many ways to do it. You know, there are tested designs, but there is a little bit of discussion that has to be had. So first of all, you have to determine what type of anchor. Do you have a top of slab anchor? Do you have a face of slab anchor? Or do you have your anchor completely under the slab? So once we figure out that, then we can address it. If it's on the top of the slab, the anchor system is generally protected, and STI has actually tested designs that allows up to 2 inches of the fist slider to be completely exposed below the underside of the safing with no additional protection. First time in the industry ever. So that would be a top of slab anchor. Face of slab anchor can, you know, need to be addressed. And what we normally will do is we increase our mineral wool depth at the anchor system and then transition back over to 4 inch in between the anchor mullion assemblies. But last, if the anchor itself is completely exposed on the underside of the slab, that is a different animal, and there is additional requirements that are needed there. So I know that that's a very general answer, but there's a lot of specifics to it. If you have a specific question or you need more information on anchor protection, please feel free to reach out, and we have detailed information we can send you and work with you on.
A couple more left, two questions. So the next one is, does a system simply have to be tested to write a valid EJ against the tested assembly, or does the system need to be listed to write and submit a valid EJ? And what's the difference between tested and listed?
Sure. Those are all great questions. So first and foremost, you know, who's writing the judgment should be your first question. Is it a, you know, qualified engineer, or is it a salesperson trying to sell product? That's number one. Number two, the code requires systems to be listed. And so, you know, that's what's required by code, and there's many reasons for it. One of the benefits of having it listed in a lab is that it goes on a consistent review process and audits. And not only that, but the system has to be checked consistently to be in compliance with listed materials. We get asked this quite a bit, especially recently because of some things that have happened. And if you look at some of the stuff that's trying to be peddled out there and you look at it, there's no compression rates, there's no information on thickness, there's just no way that those systems are going to be installed in the real world. They just don't work. So in order for a system to be legitimate per the code, it should be a referenced, published, listed design by the lab. It's right in the code section. I referenced it in in the definition section in Chapter 2. And again, if anybody has any questions on that, you could certainly send me an email and we'd be glad to send you the section. But it absolutely is in all the building codes, as well as in the state codes, including New York, and absolutely in Chicago.
Okay. All right. Another question here is, in your opinion, should architects now design their curtain wall systems using ASTM E2307 tested and listed systems as a basis of design?
Yeah, I mean, you absolutely should, because number one, it meets the code requirement. 2307 is the code requirement for listed, published designs. So yes, you should. Now, granted, there are many, many variables. That's why you want to deal with a manufacturer that has a broad base of experience. Just having a precast panel is not enough. You need experience with back pans, aluminum frames, vertical notch, window wall, eaves, the whole 9 yards, because there's so many variables, including anchor protection, as you mentioned. So it's always an awesome idea to try to promote and run with tested designs. And there are many, many tested designs now that are legitimate and real world. So the days of somebody telling you, oh, there's no tested design out there that matches, that's not true at all. In fact, many glazers have invested in actually testing their specific systems. So again, if a tested design exists, it should be used. If tested design does not exist, then an engineering data should be put together from a reputable manufacturer who has published and listed tested designs.
Sounds great.
All right, Eric, great job. We do have a few more questions in there, but we're kind of running short on time. We're up against the top of the hour. So what we're going to do is for the people that do have questions in the queue, we'll get those to Eric and or Aaron, and they'll take care of you after the webinar is over. But we just kind of want to roll through a few extra slides, Eric, if you don't mind.
Yes, sir.
All right.
Pulling it up right now. Unfortunately, I'm frozen. Here we go. Oh, sorry.
There you go. All right. So,
okay, and just one more note,
yeah, sure.
John, and I'll be quiet. I'm sorry I didn't get a chance to move this, but we talked a lot about about the actual fire stop system and knowledge and testing. If you have specific examples of the U-Wall system we referenced, please contact Mr. Joel Phelps, who's the director of Curtain Wall at Reflection Window and Wall. His information's there, and he'd be more than happy to talk to you about the advantages and information about that vertical notch system they've developed. So with that being said, John, I'll turn it back over, my friend.
Good deal. Thanks again, Eric. So as always, our webinar series is brought to you by STI. Eric's told you a lot about what's going on here, so I won't bore you with too many details on that front, but we do want to tell you a little bit about our digital tools. Not only do we put all of our R&D into fire stop systems and the testing like Eric showed you, but also the digital tools on the next slide here. So to get access, I know a few of you did have questions about the slides. They will be available as a PDF reference in our Fire Stop University. You will need to have an Access STI account to do that. So scan that QR code. That'll take you over there. You can get yourself an account, and it'll also give you access to some of the other tools that we'll show you right now. All right. So for any architects out there, we have some great digital tools that'll make your jobs a lot easier. We have guide specifications for all the different divisions and sections that you may need. We actually also offer a free spec review. So if that's something that you'd like us to take a look at for updated codes and standards and products and things like that, we certainly could do that at no charge. If you're using Autodesk Revit out there, which most of you are, all of our products are available as BIM objects. And we also have a great tool called the Firestop Clash Management, which uses clash detection for all of your penetrations and joints. It's a fantastic program that will actually select the systems for you and put the drawings on your designs if you so choose. And we also have Firestop Locator, which is a great construction documentation tool for all of your penetrations, joint systems, makes inspections really, really easy. A couple more slides. We just want to tell you, this is one of our lunch and learns. So we also do custom lunch and learn. So if you'd like to set something up for your firm, just click that QR code. That'll take you to our training page, and you can fill out a form, and we can certainly do any one of these continuing education courses for you. So if you see something up there that's of interest, we can do it as a live virtual lunch and learn, and they are also available, as you see down at the bottom, on our Firestop University. Thanks, Eric. All right, and finally, the Credly badge that we mentioned at the outset. This is something that you're going to be getting another email from Credly. This will come directly from them, and this will help you to display your knowledge of curtain wall systems, fire stop systems in general. It's a great way to put it out there. You probably have seen them on LinkedIn. So we love it when you share it. Feel free to do that. You'll be getting that in the next couple of days. Eric, we're at the top of the hour, but do we want to try to show that video? We can maybe take us out of here.
Sure, John. Sure. Would you like me to stop sharing, or do you want to take it from here?
I'm gonna try to do this without too much hiccups. So
Okay.
let's see you stop sharing, and we'll say goodbye to everyone now. We're gonna let this video play. It's about 2.5 minutes long, and then we'll end the webinar as soon as the video ends. So thank you all for joining us. Eric, do you want to say goodbye before we start sharing this video?
Thank you so much. Have a great day. And if we can be of any assistance at all, please contact us. Never too early, but you're always too late.
That's right. All right. So we will start this video right now. Got that. And take home with this. Thanks again, folks.
Thank you.
Thanks again, everyone. Have a great day. Stay safe.